Hi, everyone. Good to have you here. For those of you who don't know me, I'm Alex, Director of Technology at Kosli. And like many of you will have been, we've also been exploring what does it really mean to have AI agents in our production SDLC, and are we ready for it? So agents are writing more and more of our code. Every process we have for keeping that safe, our SDLC, our controls, was designed largely with the assumption baked in that it's a human doing the work. We trust humans to follow our process, largely. But does that same trust extend to agents? And are the controls that we all own today up to scratch for this? Or do we need to think differently? At the start of this year, we really didn't know, and so decided to find out. And that's what we're going to share today. It's a bit of the journey of how we got there. We'll do a focus zoom in on code review, what broke, so that you can learn from my mistakes, and then the answer that we've currently landed on. As Mike said, there'll be a Q&A at the end, so I'd really welcome you to take what's useful and really challenge me on what isn't, because really up for learning and shaping on this. But for a bit of fun, I'm just going to start off with a video and just see if this resonates.
Put the butter knife in the peanut butter. Take the butter knife out of the peanut butter.
You did it wrong. No.
Take the butter knife that has the peanut butter on it and spread it all over the top of the piece of bread.
Dad,
That's the top.
I mean the sides.
Take the butter knife, rub it all over the top of the piece of bread.
I quit. You're not making any sense. Sorry you ruined it on purpose. He knows how to make one.
Now, where have we seen this before? I just want to point out that this is not my wife's belief that I somehow read her mind and put it down on a slide. No, this is something being helpful technically and trying to do exactly what the instructions say and nothing that they don't. So in the video, the boy knew what he meant by on top of the bread. He just never really needed to articulate it in that certain way. And I want you to sort of keep in mind this video because it's the whole problem that we've got, but in miniature. Those instructions work fine for anyone who fills in the gaps and everyone who fills in the gaps. So it's okay. Right up until the point that the thing that's following the instructions doesn't. And I probably bet if we look at our controls, we might have the same issue. But before we get into that, let's go back on our journey and where it all started. And I'll take us back to November, because that's when things started to accelerate with better models. We at Kosli were already using AI to help us write code. But until that point, it was mostly good for autocomplete. And then quite quickly, they were showing real competence on larger chunks with detailed prompts. But we could see that bottleneck coming. Code was arriving faster, and the team was really worried about the quality angle, like every engineer is, and that AI slop. And our review process at Kosli is pretty social. A lot of our work happens in mob sessions where review effectively happens live with multiple eyes, and some of the solo work would go into the Slack channel for someone to pick up and review when they can. It works because humans are in it. But this wasn't really going to scale for what was coming. And so we love experimenting at Kosli. So we switched on the GitHub Copilot reviews. Was it really good enough to take away some of that cognitive load the review process has and keep quality as high as we have now? Humans, I'd say, through this experiment, stayed in place alongside it, and it did an okay job. There was quite a bit of irrelevant feedback, but partly because, in fairness, this was their product in its infancy. Then I'll take you to January, and the model stepped up again. I think it was Opus 4.6 in January. And so we ran a side-by-side test with Claude. And Claude had like a simple review prompt on the same code. I think it was the early infancy of its review product it has now. It was much better. So we turned Copilot off and kept Claude on. But that still left the whole kind of controls question unanswered. These reviews were still a black box. The agents, were they following our process? Were they meeting our controls? With humans, we can sort of assume it, but with a black box, we can't even check it. So there were kind of two things that led to us building our own PR reviewer. The first was about quality. So the kind of Copilot and Claude then weren't really reviewing against our code base, our standards, our patterns. Yes, we could pull out some best practices from across the world, and it did that well. But if you really care about the shape of your code and how your domain models work, generic best practice just isn't enough. A single prompt, yeah, has amazing breadth, but poor depth. So the idea here was personas, like a panel of specialist reviewers, each built from our own standards and architectural decisions and patterns and code, which kind of gave us the breadth and depth all within our own control. Then the second point leads back to the controls point. I wanted the live experiment. Could policy as code prove whether an AI process was actually compliant? Did it follow the steps that we expect? And was there enough evidence that could inform those decisions? So in February and March, in like a shadow repo, it was built. And then at the start of April, it actually went live on our product repo. Now, to give you just a quick rundown on what I built, I mentioned the personas, but yeah, imagine that you could ask every domain expert within your team to review every pull request before it merges. Specialist reviewers for security, architecture, patterns, test quality. There were 16 of them in total that managed to come up with, and they each had a large prompt built and tuned from our own code base and standards. And each specialist runs twice, once with Claude, once with Gemini, and I'll come back to why that's important later on. Then had a moderator that reads the log, calls out agreements, disagreements, resolves them with reasoning, and all of this is audited. It's written in Python with rigor policies, and you have LLMs that supply the code quality judgment, scripts control the process and produce the facts, policies decide whether the process was followed. Look, and I'll be honest, the method behind this, it wasn't weeks of design before the first line of code. It was largely just me Claude coding my way through because I had the power, running retrospectives on the reviewer when something looked a little bit off, making small changes, and the team feeding back. Now, the importance of why I said that is because it's important to the story, because my design at the beginning started with the assumption that our controls would hold as they were written. And I extended the AI the same trust that we extend humans. It turns out the retros said no 4 times in 4 different ways. And all 4 breaks pointed at the same control, our code review, and the assumptions underneath it that had never really been written down. But just let me go through the kind of the code review control we have at the moment. So this might be quite familiar, written in most frameworks, including our own, that a change reviewed by at least one peer, the reviewer isn't the author, reviews consider security and quality, evidence recorded, protected branches. This is a very simplified version. And I reckon if you've spent a bit of time with this, you'll probably come to the same conclusion as me, that not one of them really changes because the reviewer is an AI. So on paper, our control was ready for agents. But underneath those 5 lines, there are probably 4 assumptions that we make about human doing reviewing. Nobody really writes them down. Again, my assumption is because with humans, either they're so obvious or checking them costs more than the review's really worth itself, and we just risk accept. So we'll go into the 4 assumptions. So assumption 1, that the reviewer read the whole change. Now, yes, a human might rush, might skim, and we can't really prove that we've read everything because we can't get into the mind of a human. But what about an AI? Now, I've got an example here. It was, I think, Peter opened a pull request. There was 15 files and 715 lines, and the review loop giving him feedback, he kind of went through 6 rounds of iteration of review. But the later rounds kept finding issues in code, but actually they'd been there since the round 1. So I ran one of the retrospectives, and just to give an idea of a retrospective for me, it was Claude, spin up 5 agents. What's going on? Have a review of this. And the evidence that it came back actually showed exactly what happened. Out of the 15 files, only 5 were reviewed. It claimed it read everything. Now, what we can guess from the logs and see and reconstruct is it was a context overflow. The window couldn't actually hold the task, so it dropped the rest. Frustrating because it kept finding new findings, but just annoying that it said it was doing something, but it wasn't. So to fix it, the control's intent overall hasn't changed. The requirement just got spelled out properly and checked properly so that every single line of code or file altered must be reviewed. So every reviewer now produces an acknowledgement for everything it reviewed. If it's big, then it's per chunk of the diff. It's got line numbers, it's got what it found. And then we can use scripts for deterministic checks that cross-reference against the actual change. And if it's missed anything, it will trigger a re-review. And here was a lovely extra bit of learning for me, because there was at one point, one of the reviews said, okay, on the first pass, I've got 70% coverage. And then the AI announced, okay, 70% coverage. I don't need to do another review because coverage was 100%. It's like, what? Both numbers were present, both in the same breath. So again, this led to another policy rule too. And policy checks are pretty cheap in code. And I've got an example here that we've got in Rego, that so we can check AI's creative accounting and just really hold it to account. And so what you can see in this policy is the top 2 lines are the evidence that's put in, and then the bottom 2 lines there are what we don't want to expect. And if we do see it, it's a violation. Sometimes I've heard a lot of, for something so smart, it can be incredibly stupid, which is why we have these rules in place. And no, I'm not willing to admit it's just my system design. So we're going to move on to the next assumption, that the findings are real. This is a fun one. So I think it was Torde that hit this one. There was a 1-line config change, and it came back with 12 findings for 1 line. Torde is an excellent engineer. He's been around for a while, so something had to be up, and it was. None of them were legitimate. The reviewer was describing code that wasn't even in the diff. It was just a classic hallucination. We gave it a task. It wanted to complete it so badly that it made stuff up to be useful when it was exactly the opposite. Now, to be fair to Copilot and Claude, they didn't really do this. But they're still the black boxes, and I'd chosen transparency and control, which meant we had to build the guardrails ourselves. So now we build the fact, which is that a finding needs to have a specific file path and line number, or it doesn't count. And all claimed locations get checked against the diff, cited standards against what they actually say. And so then we verify them so that everything that survives goes to a separate model armed with tools, reads the file, greps the code base, and confirms whether refute it or not. It isn't just allowed to say confirmed unless it actually looked, and I can prove it looked because the tool calls it, and it's all audited. We don't just accept, trust me, I checked from the AI anymore. But we shouldn't really trust that anyway. So here we have that the kind of code review control itself gets tweaked very slightly. Assumption 3, that this is for this slide here. Sorry, giving you a preview there. The reviewer knows and applies your standards. So generally in teams, you have the appropriate person with the knowledge to review and improve the code that others who are unsure might review, but leave to someone else for the final verdict to check. With an AI, I could prove that the standards were loaded into each persona's context. So there's evidence for every review, so I know it always had the experts with the knowledge. But then again, one of Torre's changes flagged that there was a roots file that had been through 6 specialists. All 6 summarized it correctly, but we were deliberately checking how the process was working because none of them caught that there was a cross-site scripting risk that was sat in that code base. And so this was a deliberate PR that we put through to test the process and see if it was working right or not, was capturing what we expected. And it didn't. But what was more annoying is that the context in our standards and patterns should have checked that. But it seems that acknowledgement is not the same as scrutiny. So loading the standard to an AI was like, cool, loaded it, but didn't use it. With a human, you'd say, review this against our standards and reasonably expect that to happen. But with an AI, you have to be extremely explicit. Check each one of these one by one, tell me what you found on each, and it's that video again. Reviews against our standards turns out to be put the peanut butter on top of the bread. I knew what I meant. I just didn't have to think and say it in that certain way. Really annoying. But the ability to mutation test is what caught that along the way. So that's what our reviewers do now. They walk our standards one at a time and report what they found on each, and a policy then checks what actually happened. And this is sort of the shift I would really be expecting for each of you. So everything like subjective and tacit that's within your controls has to become objective and written. Now, assumption 4, that one good reviewer is enough. With humans, that generally comes down to economics. Second opinions cost time, so unless it's something really risky, we'll generally risk accept one reviewer and assume it's always the relevant person or state that has to be. But with AI, the second opinion cost is quite negligible. So I ran 2 models from the very beginning. And what I'd assumed is that they would converge, that the agreement between them would mark out what was real. And so the way it was built was to union the data. And I didn't get many findings. And it's because they essentially agreed on almost nothing. The median agreement early on was actually 0, for the median being 0. Now, I know that AIs get better over time, and so I didn't quite trust that stat now from where it was back in April, May. So I've ran the numbers over the last 2 months because they've got better. And I think there's 201 reviews. Both models ran, found something, and kind of depending on how you deduplicate, what we've got is the overlap is somewhere between a fifth and a third. But still, most of what each model finds, the other misses. They've got their own blind spots, just as humans do. So multi-model isn't just about safety through agreement, it's coverage through difference. And we've got a moderator that's sorting severity and kind of a verifier handling the false positive risk that kind of that union creates. But there's a policy in here too, because again, they have the ability through code to write cheap policies and checks. So we've got a script which checks to see what specialists ran, make sure they match, and if any haven't come back, we notify the humans who are reviewing the change so that they can see it's non-compliant and it's got a bit degraded. And so the system isn't just allowed to have a bad day without telling anyone. So these 4 assumptions, this system built sounds great, but what does it actually cost? And what's the return on investment? So in general, most reviews come in around $1 or $2. There's a few, if you've got bigger PRs, it will come out as more than that. But every round's cost is audited. So that number is a lookup, not a guess. The value, though, comes from the time spent versus the human review, which is where it's the real payoff. I think the first pass generally comes back in about 15 minutes after the review opens. And that feedback, again, is checked against their own quality and codes and standards, all checked by policy as code, and all checked to see whether it's a compliant journey or not. But what does that $2 actually get us in terms of what's actually happened? So looking at the data, the Claude is actually writing about 80% or assisting us with 80% of our pull requests now. And that's kind of since July 2025, is that we're actually at 155 PRs per month compared to 80. And that's this time a year ago. Now, that isn't with any real increases in the number of people that are working here at Kosli either. So we can already see that risk of the sheer volume of code and sheer volume of PRs increasing now that we've got that AI assisted code generation. The reviewer is how we really hold the line on that volume. And what we can also say, though, is that the humans do the review, but they move up a level. The machines check the code, follow our standards. Humans check the intent and that nothing malicious crept in. And actually, the amount of bugs was already low for our team and it hasn't increased. So we can see that that code quality is holding, even though we have that 80% increase in AI assisted code development because we're confining things within those PRs. And not just that, the time taken from the PR raise to PR merge has also held at the same, which is just under 2 hours, even though we've got twice as many to review with the same size team. So automating that process and using that agentic flow, but baking the controls into that process to ensure it's doing what you're doing has led us to that greater output and outcomes within the company, which has been a fantastic result. But what if we took this a step further then? So it's great that we've got this within the PR review and the code review process. But what about if there was an agentic end-to-end process? And we discussed this as a team when we got together in Edinburgh in March, and like what controls would we need if it was from ticket approval all the way through to merge with no human in between. Now you can sort of imagine a pipeline look like this. And again, rather than leave it as theory, I've spiked it, which is great. Thank you, Claude, for allowing me to do this. And so it can pick up a ticket, plan it, code it, have the panel review, fix it with some loops, and then it can get to the point where it's ready to be merged in. But again, I chose that the human could merge it rather than fully human agent to merge it in. And so some of the worked examples that I had for one ticket end to end was over 80 different evidence and facts it collected with decisions and policies, all on an audited trail to make sure it was compliant along the way with our controls. And I was actually looking to work out whether it was beyond the code review control. Do the other controls have the same kind of, are there new ones needed, or do we just need to adapt them again? And it was sort of the same conclusion, much more specific requirements to the existing controls, but there's, again, a couple of extra requirements thrown in. And I'll give you two of the best examples that I've come up with here. So the first one is the requirements control. It's a control that we have, but in this world, the ticket is the prompt and becomes probably the most critical artifact if you have that full end-to-end agentic system. So the moment a human approves it, I took a cryptographic fingerprint to ensure that nothing changes in that development cycle. Now, I've never seen an AI try to rewrite its own ticket, but I can imagine a world in which it might do that if it thinks, actually, I can't do this. So to be helpful, I'm just going to edit what I think I should be doing so that I look good. Don't know if that will happen or not, but let's stop it from happening by cryptographically fingerprinting the ticket. It was a control element designed ahead of the threat. So that requirements control already existed. It just kind of gained a few extra lines. And similarly to like vulnerability scanning, so prompt injection, it's just a different aspect to that scanning, which we now need to check the prompts and inputs into the AI and not just what it produced. Plenty of open source tools out there that you can run against your fingerprinted ticket to do this. So is our SDLC actually the controls for it up to scratch for agents? For a while, I did think the answer was no. Because actually I saw all these extra things as just a growing list of controls. And I thought, hang on, I've got 28 new controls at this point. This is going to be a bit of a nightmare. But just talking it over with the FinOps working group on SDLC controls, which I think Mike mentioned, these are all people working on the same problems. And it's talking through it with them that made it click. There are no new controls, as you've seen in this story. They were just sub-requirements and of sub-controls along the way. These controls already implied these things, but never really called them out. I don't know why. It's either because with humans, we can never afford to check it, or it's not practical, or we just risk accept it or assume it along the way. But the control intents all hold. But the detail has to just get much more specific, that greater decomposition. There aren't really any new inventions that I've really seen along the way. And the same for me went for risk. No new risks, because I think everything along the way was a risk that we already carry with humans or with outsourcing. It's just sort of the same thing. Yes, different vectors and potentially higher likelihoods, but I'm sure you've all got insider risk, social engineering risk, outsourcing risk, quality control risks. And to me, it's the same family, but we can just add in more granular controls. But with the AI doing it, it also opens up a new conversation of actually, have we got a greater opportunity to mitigate? Because it's no longer that kind of black box. With agents, you can live audit every single step of what they're doing in a way that was never really affordable or practical with human-only development. And that evidence side almost flips from being a burden to being the advantage. Did you read all 15 files? Is I said, unanswerable for humans. They might just say yes, but it's just a lookup for an agent. And it's sort of what I'm realizing is that zero trust is kind of finally reaching the delivery pipeline. But who's accountable? This is the question that you see debated a lot. And I'd also like to it'd be nice to ask the question, who's accountable when it goes right? But that's not one we really ever ask. It's who's accountable when it goes wrong. Where I'm starting to kind of focus on, but again, this is very much up for debate, is to do with like their definitions, being able to prove that you followed them and they were the right ones. So if something goes wrong in production, but the implementing team followed all the controls and the evidence shows they did, then the hard questions point at the control owners. The controls were followed and proved insufficient, so the definitions need to improve. But if instead the controls were defined but poorly implemented, the questions point at whoever operates the gating process. The evidence is what tells you which conversations you're having. So without it, every incident turns into archaeology and opinion, which is roughly a lot of where the industry is today. But with agents and live auditing, it really doesn't have to be. So I sort of finish off by saying, look, AI and agents are already writing a lot of the code, and the controls we need are there, but they're mostly in our heads all along. Our job, I believe, is for us to now write them down explicitly enough so that the machines can check that they're being followed, and we can check live they're being followed, and we can let the evidence carry that accountability question. Cool. Thank you all very much for listening. Hope you got something from that.